Good morning or good afternoon, geometry students. We are moving on to section 4.3, congruent triangles. And really, it's talking about congruent triangles, but we could talk about any shapes if we wanted to, congruent figures. So the objective is to name and use corresponding parts. So we'll talk about what those corresponding parts are. Let's also talk about what congruent means. We all know the word congruent. We've been using it a lot. It's equal, right? So geometric figures with exactly the same size and shape. Geometric figures with exactly the same size and shape. So notice in the little box that's marked congruent here, they look like little fishes to me. I don't know about you. But all three of those figures, 1, 2, and 3, are all exactly the same size and shape. They can be rotated around. They can be flipped. They can be turned, twisted, whatever it might be, but they're still the same size and shape. Notice in the not congruent box, figures 4, 5, and 6, it looks to me like 4 and 5 are pretty similar, except 5 is a lot smaller version. So they are the same shape, but they're not the same size. So you really have to be watching carefully. If they're the same shape and size, they are going to have equal parts. Notice on the little fish over here, this tail part is going to be the same as this tail part and the same on the third tail part. So exactly the same size and shape. So let's talk about those corresponding parts. So corresponding parts are, the whole idea is polygons are congruent if and only if their corresponding parts are congruent. So let's list all the corresponding parts. So if I'm looking at angle, or at the first triangle, the triangle ABC compared to triangle EFG, if we're looking at just angles first, name a pair of corresponding angles. Well, it looks to me like angles A and E are corresponding, right? They both have the single dashes. So angle A is congruent to angle E. They are also corresponding angles. If I picked triangle ABC up and dropped it right on top of EFG, A and E would be in exactly the same location. Remember, we can flip or rotate or whatever we need to do with these, so you still have to figure things out. This one, it's marked pretty clearly with those angle arcs, congruent arcs. Angles B and F have the double arcs. So that's telling me that these two guys are congruent to each other. They are corresponding angles. And last but not least, probably that leaves angle C corresponding to angle G. We know that they're congruent. If we picked up one triangle and put it on top of the other, they would be matching exactly. Sides, we have to watch carefully, but sides, it looks to me like side AB with the single congruent dash would go with side EF with the single congruent dash. This one you do have to be congruent. Segment AB is congruent to, I have to name that EF, not FE, because I'm going from the single arc to the double arc if we want to look at the angles, or, looking at the sides. You have to be careful. The order matters when you name these sides. Angles, we just have one letter. Let's see. So that means that side BC would have to be congruent and corresponding to FG. And last but not least, if I name this last one CA, that's going to be congruent to, would I name it EG or GE? Hopefully you notice that CA goes from the triple arc to the single, so this one has to go from G to E. So be careful on how you name those. I've always put the ABC triangle first. It doesn't matter as long as you've got everything lined up. So a congruent statement is a statement in which all of your corresponding vertices are listed in the same order. I don't know if you need to write down that parentheses. You can identify all the corresponding parts without a diagram if you have a congruent statement. So maybe you don't need to write that down because I am going to add the order in which you write these matters. So even if I don't have a diagram, if I give you a congruent statement, triangle ABC is congruent to triangle EFG, you know exactly what lines up, what goes where. As a matter of fact, let's write that down just so that you can see it. Triangle A, actually I'll name it in a different order. I could name this triangle, this left triangle, triangle BAC. Whoa. Try that one more time. My board is going crazy this morning. I'll write it up here. Triangle BAC is congruent to triangle. If I name that one first, the first one BAC, how do I have to name the second one? So whatever corresponds to B, because it's written first, has to go first. So angle B corresponds to angle F. A corresponds to E. And C corresponds to G. So F, E, G. Oh my goodness. One more time. F, E, G. All right, now I'll put that over there. Woo. All right. So the order really matters. Even if I wrote that congruent statement, triangle BAC is is congruent to triangle FEG, I wouldn't even need the diagram because I would know that, say, side AB corresponds to side EG. Everything is lined up perfectly. So you have to really watch. That would be a question on a test or a quiz. I would say, if I name this one BAC, how do I have to name the other one? Or using this congruent statement, what angle corresponds to angle G? And you would be able to say, oh, that's C because it's listed last. All right, a couple other technical things. CPCTC, since we're not doing proofs this year, this is not going to come quite as handy as it usually does, but I'm going to put that up there for you so that we can talk about it. CPCTC stands for corresponding parts of congruent triangles are congruent. So corresponding parts, CP, congruent triangles are congruent. CPCTC. In other words, if I say the triangles are congruent, then you know you can line up angle A and angle F. You can use that congruent statement. Actually, it was A and E, wasn't it? Angles A and E. Typically, this would be a reason in a proof. However, now it's just going to be a reason that we can set up equations, because if I give you in the directions these triangles are congruent, find x, you're going to be able to do that. The third angle theorem says this, and it's going to sound like common sense to you. If two angles of one triangle are congruent to two angles of another triangle, then the third angles have to be congruent. Had a little trouble spelling angles here. There we go. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. It makes sense. Let's think about this for a second. If I've got two very poorly drawn triangles, and I say this is 50 degrees and this is 40 degrees, that's really bad. Say that's 50 degrees and that's 50 degrees. Yeah, I don't want to do that. How about 55? And I know that this one is 50 and this one's 55. Doesn't the math just say that the third angles have to be congruent. Whatever you have left from our triangle sum theorem, subtract that from 180, has to be that third angle. So these guys have to be congruent to each other. In this particular case, we could figure it out and do the math. In some cases, it allows us to set up an equation, x minus 3 equals whatever it might be. All right. We've got some properties we haven't talked about much, but I just want to make sure that I point these out to you. So first of all, over here, these three little triangles over here, I'm going to call ABC triangle 1, EFG is triangle 2, and JKL is triangle 3. Having some issues over here, so we'll get this. All right, triangle 2, triangle 3. It's going to make it a little bit shorter when we write this. Reflexive property says anything is equal to itself. So I could say something like triangle ABC is congruent to triangle ABC. Seems dumb, I know, but we use this sometimes if we're doing proofs. Symmetric property, we use this all the time in algebra. Symmetric property says if I say that triangle, actually, you know what? If I say that, let's do it this one. If triangle 1 is congruent to triangle 2, then triangle 2 is congruent to triangle 1. So I can switch the orders. Think about that when we solve an algebra equation. How often do we come out with 7 equals x and then we just say, oh, well, x equals 7, right? We switch the order of the equation. We flip the left to the right side, the right to the left side. That's all that is. So it doesn't matter if I said triangle 3 is congruent to triangle 1, 1 is congruent to 3 as well then. Transitive property, I think of this as like eliminate the middleman. This one's an interesting one. I'm going to write it down here, see if it'll work, and then I'll scoot it up there. So I could say if triangle 1 is congruent to triangle 2, and then I tell you that triangle 2 is congruent to triangle 3, then what has to be true, right? If 1 is congruent to 2, 2 is congruent to 3, that means then that triangle 1 has to be congruent to triangle 3. So you can eliminate the middleman. You can get rid of the middle part of it. Oh my goodness. Today is a hard day. Sorry, guys. Who knew we would have such technical difficulties? Let's undo that. Sorry for all the trouble. All right. So just some properties, we use those if we do proofs, but we use them every day, and I just want to make sure I point them out to you. All right, so let's do a couple examples here. So first of all, it says to identify all the corresponding angles and sides and write a congruent statement. So notice these are two quadrilaterals. We've been mostly talking about triangles, but quadrilaterals work as well. So if I asked you, and I'm going to ask you to do this for a few problems, and bear with me, humor me, and then after we get this down in this section, I'm not going to ask you, or very rarely going to ask you to write out every single piece. So if I said something about angle S, what would you say it's congruent to? Angle D, right? We'll do angles over here. We'll do sides over here. What's another pair of corresponding and congruent angles? Maybe if I asked you about angle G, what would you tell me? Angle P, right? What if I ask you about angle R? Angle R must be congruent. It's got 3 arcs in it to angle E. And maybe if we were talking about, what do we have left? Angle Q. Angle Q must be congruent to angle F. So then sides, remember this is where you have to be a little bit particular about the order in which you write them. I'm going to start with segment SP. So SP goes from 4 arcs to 1 arc along the double dashed line. So that would have to correspond to DG, 4 arcs to 1 arc. It doesn't matter what order you list these guys as long as you get them all on there. So let's say side PQ corresponds to single arc to double arc. It looks to me like GF is going to be our corresponding. What about if I do side FE? Side FE goes from the double to the triple along the 3 dash side. So double to the triple is going to have to be QR. And last but not least, what side are we missing? FG, I think. Nope, I have FG already. DE. I don't think I have a DE yet. So side DE corresponds to, that's going to have to be SR. Hopefully you're seeing that. Now the last thing it says is to write a congruent statement. So this one, scooch up a tiny bit. If I said quadrilateral, if I name that first one SPQR, QR is congruent to quadrilateral, how would you name the second one if I did SPQR? So you have to be very particular. It looks to me like it's going to be DGFE. If you don't understand why I had to go in that order and no other order will work for that second quadrilateral, then you need to make sure you ask me because that's really important, the order in which we name it. All right, that's a congruent statement. I'm going to ask you to do some problems like that. Remember, when you do make your congruent statement, say angle R has to be corresponding to E because that's what the congruent statement says. Check R and E are congruent. Or maybe we'd have to say side PQ is corresponding to GF. PQ, GF, check, that's corresponding sides. So every little piece, every little order is really important in that congruent statement. If I give you that congruent statement, I could not give you the diagram and you could still make that work because everything is there for you. All right, let's set up a problem here. So now let's turn this into an algebra or perhaps just a math problem. So in the diagram, triangle ABC is congruent to DFE. Important, right? The order matters. So that means that angle A has to be corresponding to angle D. Right? Angle C has to be corresponding to E. Everything is there for you. If you want to go back and mark things, feel free to go back and mark things. Also, remember it tells you sides, like say side AC has to correspond to DE. AC has to correspond to DE. So everything is on there for you. You just have to figure out how it all puts together. Sometimes they're going to flip things over, so take a minute and look at the congruent statement. It's asking us in this problem to find x and y. Do you have a preference of what you're going to find first? I do in this case, because when I look at this problem, remember I'm always going to look for where my information is. I've got a 2y plus x on side FE, and that's going to correspond to that 38.4, but I've got an x and a y in that problem. So I feel like perhaps I should go to this angle right here. That is an 8y minus 5, and that's going to correspond, F and B have to be corresponding angles, which means they are congruent. So I'm going to have to do a problem like 8y minus 5. I could even mark these triple. 8y minus 5 has to equal 99. So when I add 5, 8y has to be equal to 104. Divide that out, that's going to be something in the teens, I think. 13 maybe? Double check, make sure I'm right. I think y has to be equal to 13. So now we said that side BC is congruent to side FE, right? So I know that 38.4 has to be equal to 2y plus x. Nobody likes an x and a y in the problem, but we just figured out that y was equal to 13. So I'm going to put that 13 in place of that y. You can do it before or after, whatever makes you happier. So when I do a 2 times y, that's going to be like 26 plus x. And then I can go ahead and solve by subtracting 26. So x has to be equal to, what's that going to be, a 12.4? Notice how it says 12.4 equals x. That's that symmetric property. We just always flip it around, and we do it without thinking, but now we know why we can do that, because that is the symmetric property. Whoa. So x is equal to 12.4. Oh, struggling. All right. Let's take a quick peek. I don't know if we need to do the whole problem. In this figure, oh, this one's a tricky one. Triangle LMN is congruent to QSR. Here's my congruence statement. Feel free to mark things. What does angle L have to be congruent to? L and Q are both listed first, right? L and Q are both listed first, so those guys have to be congruent. The diagram, they will give you extra information on diagrams, and they will tell you the congruence statement. They'll give you extra information. You have to know what to ignore. I know in this problem, you're probably going to go, oh, the y's are just in the angles, so I'm going to set those equal, and the x's are on the sides. But make sure if they give you extra information, it gets a little bit tricky. So really, my question is angle M and angle R congruent? Well, they're both listed last. So that seems like an easy thing to do. We're going to be able to set those equal, solve for y. My next question is side LM congruent to side RQ? LM is listed first and last. QR, and I just said it wrong, is listed first and last. So these two guys have to be congruent. Set those equal to each other and solve for x. That is it for section 4.3. Thanks so much. I hope you find these problems easy. There is going to be algebra, so using the congruent statement and then using that to set up algebra problems to find variables. That's it for section 4.3. See you next time.